Hello everybody, we are the group 1, Álvaro de la Fuente, Daniela Anchuela, Pablo Rodríguez, and yours truly, Alfonso Gordon, and we're here to present you COVIDIST, the application that we have been developing for the last 3 months. The application was created with the purpose of helping doctors, laboratories, and governments all around the globe managing the pandemic situation. This is done thanks to the application that registers new patients that have different characteristics such as different medications, different pathologies that might increase or decrease their probabilities of dying in case they get infected. And from that information that we get from the patient, we calculate a specific score for that patient using a formula that Daniel will explain later. And with that score, what we do is knowing which patient has the most probability to die in case they get infected by the COVID. So we can develop different vaccines and statistics and sending back to them so everyone can get safe from the terrible virus that has been isolating the world for the last year.
This is our use case for the first presentation. The final products are similar, but we have done some changes. Finally, we decided that it would be a great idea that the laboratories could see the patient data in order to help them on their investigation, but without the option of modifying their data. Also, we decided that the government should be able to notify the numbers of vaccines that they have used to optimize the number of vaccines data. This is our ER for the last presentation. We have followed this schema as the base of our application, with the main relationship between patient to doctor and patient to the lab, as many to many, and patient to government, as many to one. We have done some changes. Firstly, the app was thought exclusively for one country, but later we decided to make it global, and we had to add the attribute country name to the government. For this same reason, we had to add the attributes ID lab, ID admin, and lab name to entity shipment. And now, Danny will explain the formula.
Now we will explain the fundamentals from which we started to build the formula that we will use in determining the risk score of the patients in our application COVIDIST. When we started to model the formula, we thought that we had to give more points to those people that belongs to a higher percentage of risk. For instance, if there are more men that die due to coronavirus, there will be a higher percentage of men and women. Seems easy, more points to the higher percentages. However, this idea sometimes is not realistic. For instance, if there are 51% of men and 49% of women, the formula would give a lot of points, because 50% it's a lot, but it's not compared to the other 49%. So we will give more points to the difference of percentages. When there's a higher difference, we will give more points than if the difference between the percentages is low, like in this case. So we calculate the difference. The highest percentage of a given feature less the lowest percentage of that feature, and the letter I represents the feature. This gives us a difference, but it doesn't say nothing about the patient. So we need to associate that difference with the case that the patient that we are treating belongs to. In this case, we multiply the difference of percentages by the percentage that has the patient P in that feature I. However, this formula is giving a score to a patient just based on the percentages of that characteristic. By the moment, we are obviating the fact that some features have more importance than others depending on the number of cases that it could be. For instance, we could say that it's important that maybe 70% of men are infected, but we consider the fact that 35% of all patients suffering from cancer, with all the possibilities that it could be, is something that we have to take into account. So this score that we have now will be more important if we have more possibilities like other pathologies than if we have less possibilities like sex, that we only have 2, men and women. The score will increase exponentially as more possible cases we have. So we raise the score to the power of 1 dot the number of cases of that feature, which is mathematically 1 plus the number of options of the feature divided by 10. In our application we have diseased and infected people that provide us with data. We will always give more importance to the data of diseased people because we want to prevent deaths. The minimum value of the importance diseased people data will be 65%, then the maximum importance of just infected people data will be the other 35%. This will happen when we have very few deaths. The application will be changing the value of the importance depending on the average of deaths of the last 7 days. For instance, this could be a possible curve of deaths. If we are at this day, the average of deaths is growing faster, so the application will increase the value of importance of diseased people data. And how the value is going to change? Like this function. If the average is higher, the importance of the data will be near to 100%, and if it's low, the minimum value will always be upper than 55%. This is the formula of this function, and we have to adjust it to our values. This is for diseased people, so this is for diseased people data, and the complementary value to 1 is the value of just infected people data. So the score will be multiplied by the value of the importance of that type of feature, if the value is from infected or from diseased people, depending on the case. And the final score of the patient P in a day D will be the sum of all the contributions of all the features.
So as you can see here, this is the UML for the application. There is one massive package that is the graphical user interface. It's so big because it needs to code every single button, window, image inserted that exists in the application. The second one is here, the one with the pollos. We can say is the root of the application because it includes the pollos of the patient, the administration, the laboratories, and the doctor. The third one is the JPA here for the login. As you can see, the user and the role it takes in the application, if it's an administration, if it's a laboratory, or if it's a doctor. And the last two ones are the one for all the JDBC, controlling all the amount of data that we have in the database. And at last but not least, the smallest one, that is the XML package with the methods for marshalling, unmarshalling, checking that the unmarshal has a specific pattern so all the data can be filled, and then turning the XML generated by the marshaller to the XML format so we can upload it to the web that we have developed.
And now, if you want to see the demo of our app, you just have to launch it, press here the YouTube button, and see this video, how does our application works. Hi everyone, and welcome to the demonstration of the app COVIDIST. As you can see, this is the window that it will appear when you launch the application. It has some buttons and some boxes. For example, this one with the GitHub logo will redirect you to our GitHub repository, this to our YouTube channel. If you click on this image, it will be our web page. And here are the user and password for entering the application. Now we don't have a user or password, so let's check register. As you can see, we have 3 different types of accounts: doctor, laboratory, and administration. Today we are going to register as a doctor. So username, it will be an email, doctor5@gmail.com. Password name Paula Perez. It's female. Birth date 990804. Collegiate number, let's put a random number of 9 digits. This should be 9 digits always. A hospital La Paz. and on specialty oncology. And we press this button, create a user. It says wrong name. That shouldn't be there. That's a bug of the application. And here it's what it should appear from a first instance, that is doctor register. We check OK. And now, as we have three types of account, we have three different views of the application. Let's start with doctor. Check enter, and this is the doctor's menu. You can see Paula Perez, what would you like to do? If we click here on change picture on this button, it will redirect us to the file browser in order to select a file, and if that file is a suitable photo, it will appear here. And we have the functionality of the app, three different buttons. Add patient. Well, here you will add the patient information, name, social security number, birth date, country, sex, blood group, height, weight, hospital. The place is where is he or she passing the disease, for example, on the ICU, on the floor of the hospital, or at home, and if it is vaccinated. Once you have confirmed this personal information, you will have the chance of add medication and other pathologies in order to make the statistics better. If you press the button search or modify patient, you press use the table, and it will appear a table with all the patients that now we have. You can sort it, for example, by name, by sex, by height, by whatever you want, by infected, for example, or by the date they are introduced. You can also filter the date that they are introduced by these two calendar likes boxes, and you press the button filter, and all the patients that have been introduced between those two dates will appear on the table. And also you can search by, for example, this blood type A plus. You press this button, and all the patients with the blood type A plus will appear. This table will just show you those with A plus blood type. And now we have the button modify. For example, we have Mark Evans. We check modify, and for example, he's going to change and to be moved to another hospital. For example, La Paz. We press this button, and Mark now will be in La Paz. And here it will also appear La Paz. And the last button of the doctor is modify my own data. For example, Paula Perez also is changing her hospital, and she is changing to the Gregorio. We press this button, and now Paula is on the Gregorio Marañón. Now let's sync out from the doctor and sync in as laboratory. lab1@gmail.com, for example, and check enter. What would you like to do? We see a very similar menu. In this case, the laboratory is Pfizer. We check view statistics. This is an option only for the laboratories. You can see, for example, from the infected people by age. It's the infected people in a pie chart by age, by patient location, medication, other pathologies, blood type, and whatever you want. You can also see the diseased curve and the infected one also. And you can also, from the diseased ones, you can see the statistics and the charts by each feature. You can also search a patient as in doctor. The only difference is that the laboratories can't modify the data of the patients. You can send a new shipment and add a new batch of vaccines. For example, this laboratory has 800 vaccines. Let's put 100 more. They have now 900. Send new shipment. Let's send 100 to USA, for example. We have also sent some more and another 100 to Spain. We press the button send, and here it appears the recent shipments from this laboratory with the date, the number of vaccines, and the country they are aimed. We have also the modify my own data as we had in doctors. Now let's sync out and view the last part of the presentation, that is the administration part, the government. For example, let's enter as USA. Let's click the button enter. We can see view the total number of vaccines. This is how many vaccines we have, and the recent shipments with the laboratory names, the date, and the amount of vaccines. This is the last that we have done on this presentation. We have also the trigger a simulation. If we click the button simulation, it will appear the patients that are in USA sorted by score. The score is, as Danny has said on the presentation, that you can see it, a punctuation in order to see who should be vaccinated first. And we can see also a PDF report. We click this button and this will appear with all the patients, and we can just save it as PDF. And the last one is notify vaccines used. For example, we have vaccinated 100 people, so we just notified it. We can modify the user data, and this is all. Thank you everyone for watching this video. So now let's see the web page.
This is our website. We have created it with Wix application, which is an online web page design tool. As my colleagues have previously commented, COVIDIST consists of an application to monitor patients with COVID-19, where governments, laboratories, and doctors around the world have access to them. On our website, we can find a homepage where the application is explained. On the other hand, we have two more buttons, one of them where we find our customers, who are the doctors, laboratories, and government. Each customer has a short description of what they can do. If we click on Learn More, it will redirect us to another page in which we will find a table of doctors in the first link, a table of laboratories on the second link, and a table of governments on the third link. These tables have been created with the XML code from the database and then exported to HTML for use on the web. If we click on the COVIDIST name, it will take us to the home page, and from there we can scroll down. While scrolling, we will reach the area where our images appear, starting on the left with Dani Anchuela, followed by Álvaro de la Fuente, then Alfonso Gordon, and finally Pablo Rodriguez. At this point, you may have noticed that on the right side we have three LinkedIn symbols, which redirect to the respective account of Álvaro, Dani, and Alfonso. We also find a button where we can start a conversation with a bot to ask for things or simply to leave our data. If we continue to go down after this, we will find the contact us from where you can leave us your information and we will get in touch. We also get to this directly from the home page by clicking on the contact us button. Finally, you will have noticed that there is also a YouTube symbol. If we click on it, it will directly get us to the YouTube channel where this video that you are watching right now will be uploaded. On behalf of the entire group, we want to thank you for taking the time to view our presentation. The COVIDIST group says goodbye.